Let's take a look at a couple application problems we can solve using this idea of a chart and overlapping right triangles to find missing sides. So this first example, we want to find the depth of this pool. Well, this is the distance we're going to find right there for the triangular portion of the pool. All I'll need to do at the end to find the total depth is just add on this 48. So just keep that in mind, that at the end, we'll add this on to whatever h comes out to be. So I've set up the chart that we've talked about in the previous videos. So here's the small triangle in this diagram. I can see that 64 is my hypotenuse, so I'll get that in my chart. And I can see that h is the medium side of that triangle. Moving then to the medium-sized triangle, let's do that one in blue, I suppose. That's this triangle right next to it. Now that top side's not 165, that's the entire triangle. In fact, in this triangle, h is the short side, and then 152 is the hypotenuse. So right now, if I just use those two triangles, I can't write any proportions. I don't have a consistent proportion. Things don't match up in the same columns. So I'll need to do one more triangle, and that's the overall triangle, the complete large triangle. And this time I know all the sides of it. 165 is my hypotenuse. The short side is 64. And then the medium side is 152. To write a proportion, you just want to make sure you pull numbers from the same columns and be consistent. So for example, if I use the top two numbers, they come from the second and third columns in my chart. So if I match up h over 64, I just need to make sure I use the second and third columns again. So this won't be good since there's a number missing right there, but these two numbers should work out just fine. So h over 64 can equal 152 over 165 to solve this proportion, or to write this proportion. Once I solve that, I'm just going to skip to my answer because I think at this point you guys know how to solve proportions. If not, now would be a great time to go back and watch a video about one. But if I round this off, that comes out to be about 59 inches. So that triangular portion of the pool, that depth is 59 inches. Well, recall, we want the total depth, and so what I'll need to do is add on that original 48 from the rectangular portion of the pool. So I get a total depth of approximately 107 inches. And one more application problem we'll take a look at. Using a square piece of cardboard to kind of estimate the height of a wall, we can once again use similar triangles to do this. So I've set up my chart. Let's take a look at the small triangle that's formed down here. I can see that the short side and medium side are what I know. So in my chart, the short side of that triangle is 5. The medium length side of that triangle is 8.5. Moving on then to the medium triangle. Let's trace that one out. Let's use orange, I suppose. The medium triangle is this one up here. So I can see the short side and the long side. The short side and the medium side are the two that I have. So the short side is 8.5. The medium side is W. In this case, I don't know how long it is. And I don't have the hypotenuse. I don't really need it. I suppose up here, just real quick, I could find the hypotenuse of that small triangle if I wanted to. I could use Pythagorean theorem to do it. Now, nothing says I need to do it at this point. Maybe sometime, though, that might be helpful to do. It looks like actually I can write a proportion even from right there. However, let's go ahead and just, to be consistent with what we've been doing, let's find the sides of the entire triangle if I can. This time I don't have the medium side. Oops. I don't have the medium side or the short side. I can, however, figure out what this entire side is. Going all the way from the top to the bottom to find that hypotenuse, adding W and 5 together will get me W plus 5. Well, it turns out that that's kind of irrelevant for the chart. I won't use that to write the proportion, but isn't it good to know? I don't know, maybe not. Anyway, we already said I could write the proportions. Let's go and do that proportion. So 5 over 8.5, those are the first two columns in my chart. So I'll have to make sure I use the first two columns again when I finish my proportion. So 8.5 over W. So once again, I trust that you know how to solve a proportion, so I'll leave that to you to do, cross multiply and then divide by 5. So W comes out to be 14.5 when I do this. Now, we didn't really read the question, but the question was, what is the height of the wall? It's not 14.5. If you look at your diagram, 14.5 is just the distance from the top of the wall down to where your eyes are located for that distance. I'll need to find, for the total height, add on this 5 down here. So let's just take 14.5, which is that part we've estimated for the top, and then add on 5 feet. to get a total height of that wall to be about 19.5 feet as our estimate.